Algebra 2, we are in Chapter 6. Oops, oh goodness. Chapter 6, Section 4. Okay, first of all, solve. Yeah, type in your calculator 1 divide by root 305. And we get 0.057 and some change. Here to solve, we actually need to get in the numerator spot, equals 1, and then divide both sides by your decimal. I'm left with root n equals 40. Square both sides, and you get n equals 1,600. The mean score on an exam was 78. You scored within 5 points of the mean. If x equals 78 plus or minus 5 represents your possible score on the exam, what is the range of your score? Well, 78 is going to be in the middle, and minus 5 and plus 5. That is your range. You could write it like this. You could write it, let's see, I don't know, your score. There's lots of different ways to write it. This is what the book reported. Okay, let's talk population. Population is a group of people or objects that you want information about. When it is too difficult, time-consuming, or expensive to survey everyone in a population, information is gathered from a sample or subset of the population. Some methods for selecting a sample are described below. In a self-selected sample, members of a population can volunteer to be in the sample. In a systematic sample, a rule is used to select members of a population, such as selecting every other person. Here, self-selected, volunteer. Here, systematic, what they did every other person. In a convenience sample, easy-to-reach members of a population are selected, such as those in the first row, right? In a random sample, each member of a population has an equal chance of being selected. It's just a random drawing. Put everyone in a hat and pull out 4, 5. 1, 2, 3, 4, 5. 5. So let's use that. A sports writer wants to survey college basketball coaches about whether they think wooden bats should be mandatory throughout college baseball. Identify the type of sample described. The sports writer contacts only the coaches that he has cell phone numbers for in order to get quick responses. Let's see, I mean, you think about the last 4 examples. I'd say that's pretty convenient because he just happens to have phone numbers for those people. So I would say convenience sample. The sports writer mails out surveys to all the coaches and uses only the surveys that are returned. Well, that means a coach can choose whether or not to respond. So that'd be self-selected. Moving on, bias in sampling. In order to draw accurate conclusions about a population from a sample, you should select an unbiased sample. Okay, an unbiased sample is representative of the population you want information about. A sample that over-represents or under-represents part of the population is a biased sample. Concert attendance. The manager of a concert hall wants to know how often people in the community attend concerts. The manager asks 50 people standing in line for a rock concert how many concerts per year they attend. Tell whether your sample is biased or unbiased. Explain your reasoning. Well, let's think about it. The manager at a concert hall asks 50 people standing in line for a rock concert how many concerts they attend per year. I would say that is definitely biased because they're standing in line for a concert. Therefore, they probably attend a lot of concerts. Yeah. So how do we choose unbiased samples? Although there are many ways of sampling a population, a random sample is preferred because it's most likely to be representative of the population. So we want random. You are a member of the prom committee. You want to poll members of the senior class to find out where they want to hold the prom. There are 324 students in the senior class. Describe a method for selecting a random sample of 40 seniors to poll. I copied the answer from the book in here because it was a lot of writing, and their handwriting is easier to read than mine. So what we could do is make a list of all 324 seniors. Assign each senior a different integer from 1 to 324. I would go alphabetical. And then, the first person with the A as a last name is 1. And then, the W, X, Y, or Z with a last name is 300 and whatever. So each person gets a different number. There are things you can do. There are websites, which are random number generators. But you can also use your calculator, which we'll see on the next page. It's pretty cool. You can do 40 unique random integers from 1 to 324 using the random integer, that's what that stands for, the random integer feature of a graphing calculator. The screen at the right shows 6 such random integers. So we've got 1 to 324, and this is everything it spits out. If, while generating the integers, you obtain a duplicate, discard it and generate a new unique integer as a replacement. Now we want to choose the 40 students that correspond to the 40 integers you generated in step 2. Okay, you can go ahead and practice that. I've never used that before, so I did practice it. You hit the math button and then go over to PRB, and number 5 is random integer. Random integer. Select that and then type in, just like you see, 1, 324. Close your parentheses and hit enter. My first number was 260, 308, 168, etc. Okay, let's practice that. A school website. A computer science teacher wants to know if students would like the morning announcements posted on the school's website. He surveys students in one of his computer science classes. Identify the type of sample described and tell whether the sample is biased. So surveys the students in one of his computer science classes. I would call that very convenient because he didn't have to do any work to go find those students, did he? Convenience. And that is going to give you a very biased view on his survey because they're computer science students who are on their computers quite often, so maybe they would enjoy posting the announcements on the website. What if in example 3, what is another method you could use to generate a random sample of 40 students? Well, we can do the whole, put names in a hat. Ooh, not hate. Haha. Put names in a hat. Or put numbers in a hat. Yeah, those would both work. You wouldn't need any technology for it either. All right, moving on. Sample size. When conducting a survey, you need to make the size of your sample large enough so that it accurately represents the population. As the sample size increases, the margin of error decreases. The margin of error gives a limit on how much the responses of the sample would differ from the responses of the population. For example, if 40% of the people in a poll prefer candidate A, the margin of error is plus or minus 4%. then it's likely that between 36 and 44%, which is plus or minus 4% of 40 of the entire population prefer candidate A. When a random sample size n is taken from a large population, the margin of error is approximated by this formula. Margin of error is plus or minus 1 divided by the square root of n. This means that if the percent of the sample responding in a certain way is p, expressed as a decimal, then the percent of the population that would respond in the same way is likely to be between p minus 1 over square root of n and p plus 1 over the square root of n. Let's use it. In a survey of 1,011 people, it's an important piece of information, 52% said that television is their main source of the news. What is the margin of error in this survey? Okay, we're going to answer that question and then give an interval that is likely to contain the exact percent of all people who use television as their main source of news. So if we look at this, we want the margin of error formula. We know the margin of error is plus or minus 1 over the square root of n. We know that our sample size is 1,011 people. So our margin of error is about plus or minus 0.031, okay, using a calculator. Therefore, my margin of error is about, change that into a percentage, 3.1%. Part B, to find the interval, we're going to subtract 3.1% and add 3.1% to the percent of people surveyed, okay? It was 52% said they liked television. So if we subtract 3.1%, we get 48.9%. Well, let's not do that. And 55.1%. So it's likely that the exact percent of all people who use television as their main source is between 48.9 and 55.1%. Try another one. A polling company conducts a poll for a U.S. presidential election. How many people did the company survey if the margin of error is plus or minus 5%? So now we need to work the equation backwards. We have 5%, which we change into a decimal by going this way, 0.05, and that's going to equal plus or minus 1 over the square root of n. Okay, we're going to square both sides. It's actually easier than what we did in the warm-up. If I square both sides, on the left, I get 0.0025, and on the right, I get 1 over n. Now I can cross multiply and divide both sides by the decimal, which is exactly what we did in the warm-up. And I get n equals 400 people surveyed, which is C. Okay, let's try a few practice problems. The internet, a survey of 1,202 people, 11% said they use the internet or email more than 10 hours per week. What is the margin of error for the survey? So we're going to do that as part A. How many people would need to be surveyed to reduce the margin of error to plus or minus 2%? That's going to be B. First of all, for A, I'm going back to the equation. My margin of error is 1 over the square root of 1,202. and that gives me 0.029. So the margin of error is plus or minus 2.9%. Now, how many people need surveyed? That's going to be, I need a plus or 2%, 1 over the square root of n. I'm going to square both sides. That's a squared. Okay, cross multiply, I have 0.0004, n equals 1. Divide both sides by the decimal. I have n equals 2,500 people. You'd have to survey a lot more people to reduce your margin of error to 2%. Hey, we made it. Homework quiz, good job. Proud of y'all. Go ahead and practice these if you need. If anything, these are easy just to read through and figure out what the answer is without any math calculations that need to happen. And the last one. Good job.